So I want you to look at this beautiful work of art we have here. And I want to make sure that one of the things that you got out of yesterday, how to actually use this. So our ordered pairs represent our trig values for these angles, right? Is the x value sine or cosine? Cosine. And the y value is sine, right? And it's alphabetical, just like x and y are alphabetical, cosine and sine are alphabetical. So if I want the cosine of 2 pi thirds, okay, you can use your unit circle, find 2 pi thirds. What is the cosine of 2 pi thirds? Negative 1/2, because look, here's 2 pi thirds. Here's my ordered pair. The cosine value is the x value, so it's negative 1/2. Make sense? What is the sine of 2 pi thirds? Square root of 3 over 2, right? Okay, what is the cosine of 7 pi fourths? Seven pi fourths, the cosine. Square root of 2 over 2. Here's 7 pi fourths, square root of 2 over 2, right? Okay, what about the sine of 7 pi sixths? Negative 1/2 right here, okay? Yes? We good on that? So you need to understand how to use the unit circle, how to pull values off of it. Now, you're not always going to have a full circle to look at. You're not always going to have time to fill out an entire circle if you need one value, but you need to know how to use this. Then I'm going to explain to you some ways to just know the values when I ask you, and you don't have to picture the entire circle, okay? All right, so you can close that. I just wanted to make sure you were looking at yours and knew how to actually use yours before we moved on. So now I want you to get here. I'm going to push you out of your comfort zone a little bit today. Know that it's okay to be wrong. I'm wrong all the time. Y'all know that. I can't hide that. And we'll fix it. But without looking at your unit circle, without talking to your neighbor or looking at your neighbor's paper or whatever, I'm going to have you fill in some values. I'm actually going to get you started more so than I tried second period because I realized vocabulary-wise you're not as comfortable with it yet, so they really had no idea what I was talking about. We're going to fill in the angle measures here in radians. Okay, so we're going to start with 0. Okay, so we know in degrees this is 90 degrees, right? What is 90 degrees in radians? Pi over 2. Okay, so then without talking to each other, without looking at each other's paper, without looking at your unit circle, I want you to fill in the other 3 to the best of your ability. Okay. You can always mark it out or erase it if you're wrong. It's okay to be wrong. And you only have 3 choices, right? Okay, so 5, 4, 3, 2, 1. Okay, so if this is 0 and this is pi halves, what's this? Pi fourths, okay? So then the other ones are pi thirds and pi sixths. We just got to make sure we get them in the right spot, right? Which one is smaller, pi thirds or pi sixths? Pi sixths, because it's like 1/6, right? So this is the smaller angle. This is pi sixths. This is pi thirds. Okay, so you also want to be able to, even though you're not always going to have a big circle, visualize where it is in the circle. Like whether you close your eyes or not, you should kind of be able to see where they are. Pi thirds is 60. Pi sixths is 30, right? So the 6 and the 3s are switched. Okay, make sense? We good? Okay, so now I'm going to walk you through. We're going to get our ordered pairs put in here without looking at anything. 2 of these we should already know 100% without messing them up. Fingers crossed. What is this one? 1, 0. Sometimes you might want to think for a tick before you say it because I know that sometimes it just comes out wrong even though you know it correctly. What's this one? 0, 1. Okay. So then for the other 3 ordered pairs, we only have 3 numbers we get to use. We use 1/2, square root of 2 over 2, and square root of 3 over 2. Those are the only ones we get to use, right? We just got to get them in the right spot. So which angle has the ordered pair where the x and the y are the same value? Which angle measure? Pi over 4, because that's our isosceles right triangle, right? So the one that has 2 values that are the same is the square root of 2 over 2. It's the one with all the 2's. So this pi fourths is square root of 2 over 2, square root of 2 over 2. And then we're done, because that only works for the pi fourths. The pi thirds uses these two values, and we just got to get them in the right spot, okay? So the first thing we want to make sure we understand, is which one of these two values is bigger. And that's based on the, or smaller, whichever way. And that's based on the numerator, right, since it's divided in half. Is the square root of 3 bigger or smaller than 1? Because look, we would have the square root of 1, square root of 2, square root of 3, square root of 4, right? This is 1, this is 2. These two numbers are between 1 and 2, okay? So you don't have to know exactly what it is. Just know the square root of 3 is bigger than 1, right? Which means this fraction is greater than this fraction, right? Okay, that's what we need to understand. So then, if you're picturing it, and you know where pi sixth is, and you know how to plot points, which you do, you know that you're going to go to the right farther than you're going to go up, right? So since I'm going to go to the right farther than I'm going to go up, my x value has to be the square root of 3 over 2, and my y value has to be 1/2. For this ordered pair, I go up farther than I go to the right, so I know that this has to be 1/2 square root of 3 over 2. Okay? Does that make sense? Now that's one way. I'm going to give you a much easier, better way, but everybody's brain works a little bit differently. So you're just going to have to connect with whatever makes the most sense to you, or you make your own thing up or whatever, but I'm going to give you so much you're not going to need to make anything up. It'll be fine. Okay, are we good with that? What questions you got? Okay, so now I want you to fold this in half with this on the outside so you can see the other one that looks like this without seeing this one. So now you can see a blank one, but you can't see what you just wrote, and you can't see your unit circle. If you fold it backwards, you can always just flip it around. But you want this on the outside. All right. So now, once again, I want you first just to write in the radians. Write in the degree measures. I'll give you the first one. It's 0. Just the angle measures. And then double check yourself with me. Do we all agree with that? Yes? Not so bad, right? Okay, so now without looking at anything or talking to anybody or looking at anybody else's paper, I want you to do the best you can to fill in the ordered pairs. When you finish, check yourself up here, see if we agree. And look what an expert you already are, right? It's not that bad. And it's going to get easier and easier and easier and easier, I promise. If you stay with me and do what I'm asking you to do. Okay? We all good? So we are going to look at one of the most useful things for knowing our trig values. Okay? And it's a hand trick, which that's my first year that I taught this. I attempted to just use it, explaining it with my hand and having the students do it, and like it did. So I was like, we need a physical little hand in front of us. So I want you to take this hand. So this is like your left hand, palm up, right? Probably a little smaller, but that's what it's representing. So if you take this and you put this on this coordinate plane right here, I know that it doesn't fit exactly. Okay, and your hand isn't going to be exact either, but do you see how the pinky's on the x-axis? The thumb is on the y-axis. Your middle finger is pi fourths. This one's pi sixths. This one's pi thirds, right? So when you hold up your left hand, palm up, it represents the first quadrant. Here again, we have x-axis. This is pi sixths, pi fourths, pi thirds, pi halves, okay? And this is going to be, like I said, become very, very helpful to you. we wrote, or we glued down on top of some words. So we're going to have to fix these words here. And so these words, it was a big old fraction bar, then a big old square root sign. It says number of fingers over 2. That's what it said, number of fingers over 2. All right, so remember a couple of things. Well, first, let's go on page 74. We also know that our ordered pairs are always cosine theta, sine theta for a unit circle, right? This is our left hand, palm up. Our pinky is at 0 degrees. Your ring finger is at pi sixths. Your middle finger is at pi fourths. Your index finger is at pi thirds. And your thumb is at pi halves. And we are not going to debate on whether or not a thumb is a finger for the purposes of our activity. A thumb is a finger, okay? So, end of discussion. All right, so here's how this works. We're going to take pi thirds, okay, that's your index finger, and you're going to fold it back. Okay? And then inside of here, we're going to write the ordered pair, and I'm going to show you how this works. So we know it's always cosine, sine. It's cosines on the left, sines on the right, right? So when we bend back our index finger, to the left of our index finger, we have one finger left, right? So we take the square root of 1. What's the square root of 1? 1, and we put it over 2. So that means this is 1/2. To the right of pi thirds, we have 3 fingers. We take the square root of 3, which is the square root of 3, and put it over 2. Square root of 3 over 2. And that's how it works. So if you look up here, I'll hold my hand. I don't like doing it under the document here. So this is my first quadrant, right? This is pi thirds. So when I do this, and I say that, what is the cosine of pi thirds? It is 1/2. The sine of pi thirds is square root of 3 over 2. This is how I know what it is from my fingers. Does that make sense to you? Okay. So we're going to fold this back. We're going to take our middle finger and fold it. And we're going to get our ordered pair. To the left of pi fourths, I have 2 fingers. So that means the x value is the square root of 2 over 2. To the right, I have 2 fingers, which means the y value is the square root of 2 over 2. Okay? Then we fold that back. Then we take pi sixths. That's your ring finger. We're going to fold it back. To the left of pi 6, we have 3 fingers. X value, square root of 3 over 2. To the right, we have 1 finger. It's 1/2. Whoever figured this out is a genius in my book, because I think this is the most helpful thing. I still use this too, okay? I mean, I've known my unit circle values like forever, but just like 0, 1, and 1, 0, sometimes, especially with pi thirds and pi 6, like even though you know it, sometimes things just come out backwards, so I use it just to make sure I've got them straight so I'm not overthinking. And it's going to look like when you're taking a quiz sometimes like you're playing air guitar, right? That's fine. That means you're using it. I always have students after, we were fully into trig, they're like, yeah, I never really got the hand trick. That's a problem. If I need to re-explain it to you 1,000 times, I will, because you need this, all right? I still use it in calculus. Every time we have to say, I say, okay, what is sine of pi thirds or whatever? I stand at the front of the room and we go, okay, pi thirds, what is it? And that's the way we still know it. It's like SOHCAHTOA. You're going to use it forever and it's fine. Okay, it's not like you need to be embarrassed because you look like you're playing air guitar. Now, the 0 and the pi halves, those are really easy ordered pairs. We don't necessarily need it, but I want to show you that it works. So bend your 0 back. Make a little ordered pair here. To the left of 0, I have 4 fingers. The square root of 4 is 2. Over 2 is 1. To the right, I have 0 fingers. So if that helps you get the 0 in the right place, do what you got to do, all right? If I bend pi halves back, to the left, I have 0 fingers. To the right, I have 4, so I take the square root of 4 and divide it by 2, and I get 1. You see how that works? We good with that? Okay, so let me show you again. I guess I feel like I need to be on the video. So with your real hand, if I wanted pi 6, I'm going to bend my ring finger back. So then I have square root of 3 over 2 for cosine and 1/2 for sine. See how that works? Okay, questions on that? We good? Okay, so let's flip this over. Let's talk tangent values real quick. I'm going to give you a mnemonic for your tangent values. Now, this one, so SOHCAHTOA is universal. The hand trick, I think, is pretty universal. This one was made up by some random person, and I stole it from them. They needed it when they were in college. I told them I stole it from them, though, so it's fine. But something got cut off, I think, even on your copy. This is the word U, so the Y, I mean, you can tell it's U. But then this in-def, there's a U in front of it that's missing. It stands for undefined. So just add that little U in there. Okay, so this sounds really strange, and it's pretty creative, but, you know, it's one of those, hey, you got to do what you got to do, right, to learn things and remember them. So the sentence is, you are one really overwhelming third wheel. Here's the way this works. The U stands for a U for undefined, okay? Whether the word is R or starts with an R, it is the square root of 3 because a square root sign kind of looks like an R, okay? And the square root of 3 is the one we're using. So the R is the square root of 3. 1 is 1. Overwhelming is a fraction bar because it's over. Third is 3. Wheel is 0. Okay? So you see how that translates? So this is the way it works for our tangent values. Well, first of all, let's go ahead. Let's fill in our angle measure. So this is 0, pi 6ths, pi 4ths, pi 3rds, pi halves. Notice that your denominators decrease as you go around the circle in the first quadrant. Okay. All right, so then this is how this little mnemonic here works. So my tangent values, starting here. U is, oh, I just realized we didn't come up with our tangent values first. I got ahead of myself because my board crashed. Okay, let's back up. Pause on that for just a second, and let's come back over here. I'll get my act together, I promise. Just come back to one of these two, because both of these on your other piece of paper look the same, right? The ones you already have filled in. Okay? So not on the bright yellow, not on the bright orange one, I'm sorry, on the other paper. I know it's confusing. Go back to the first piece of paper. You already have all this filled in, right? So let's talk tangent, because I got ahead of myself. So tangent theta, we know from SOHCAHTOA is opposite over adjacent, right? From the unit circle, tangent theta is what over what? Sine over cosine, good. Because sine is your y and sine goes on top. So sine over cosine. All right, so we're going to come up with these. I'm going to write some stuff off to the side that looks like it's off my paper. You don't necessarily have to write that down. It's just going to be us coming up with things. But what I write on this circle, I do want you to write on there. Okay, so since tangent is sine over cosine, that means I can start here. Sine over cosine is going to be y over x. So I put 0 over 1. What is 0 over 1? 0 divided by 1 is 0. Okay. Yikes. All right. 1 over 0 is undefined. Okay. We good with that? All right, so now we'll do pi thirds. That's going to be sine over cosine. So, and you're not going to have to do this work every time, but I want you to see where it's coming from. Square root of 3 over 2 divided by 1/2. That's what's happening. So that's the square root of 3 over 2 times 2 over 1. That's where we get square root of 3. Okay? Then if I put square root of 2 over 2 over the square root of 2 over 2, what am I going to get? 1. Then 1/2 over the square root of 3 over 2 gives me 1/2 times the square root of 3 over, no, it doesn't. It gives me 1/2 times 2 over the square root of 3, which gives me 1 over the square root of 3. And what does that become? Square root of 3 over 3. So these are our tangent values. Now, you could, if you had to, figure them out, if you need to figure them out. But you don't have to do that every time, because we're going to have a few ways of remembering this as well. First of all, these two, even if you had to kind of figure them out or think about them each time, that's not that big of a deal. It may be for some of you that don't know what 0 over 1 is, but you need to learn those things. This one's pretty simple too, right? So these two, it's either the square root of 3 or the square root of 3 over 3. Again, you're limited to choices. The way I remember it is that the square root of 3 goes with the value that has a 3 on the bottom. The 2 3's go with a 6 because it takes 2 3's to get a 6. Okay, that's not why it is what it is, but that's the way I remember it in my brain anyway. Okay, and then we'll talk about some other things. Okay, we good on our tangent values? Now let's go back to the mnemonic that's going to help us, and then we're about to come right back over here. I'm just warning you. So just keep this one handy because we're about to come right back to it. Okay, so this U R one really overwhelming third wheel. So we just talked about the fact that this one is undefined. So U, which is undefined, R, square root of 3, 1, really, so that's another R, so square root of 3, overwhelming third wheel. You are one really overwhelming third wheel. Okay? Now, but again, you're not always going to want the entire quadrant. Sometimes you just want pi thirds or just pi sixths. And that's why, to me, knowing that pi thirds is the square root of 3 and pi 6 is the square root of 3 over 3 because of the 2 3's, like, that's just better. But if I had to fill it all out and I was literally filling out a circle, I'd probably think through that so I could just fill it in quickly. But again, whatever works for you, right? You're not always going to have a full circle in front of you. If you've got to jot things down, not the end of the world, but you don't have time to fill out the entire circle every time either. Okay, we good? All right, so now let's go back to the other sheet of paper again. I know it's back and forth. I'm sorry. I'm not really sorry, but. Okay, so now I want you to look at one of your full blank circles. These little lines are fraction bars for your angle measures. I regret putting them on there now, but they're there. That's what they're for, okay? So I want you to fill in the first quadrant, just the first quadrant, just the angle measures. Do that for me. We should be experts at this by now. Okay, so we have 0, and we have pi sixths, pi fourths, and pi thirds, right? All right. Now, we're going to fill in some more stuff. Even if you know how to fill in the entire thing, I want you to stay with me because I'm going to do things a couple different ways at different times we do it, and I want to look at some different patterns because, again, one pattern might make more sense to you than the other. So let's start with, if this is 0, this is pi halves, right? This is 2 pi halves, which means it's pi, right? What is this number? Think fractionally. 3 pi halves. 1 pi half, 2 pi halves, 3 pi halves. Okay, so we know that this is 0, 90, 180. What is this in degrees? 270. Okay, that's something you kind of need to know too, just to make things easier. But if you don't know what this is in degrees, it doesn't matter, but you need to know what it is in radians. All right, so we're going to think fractionally again. We're going to start with our sixths. Okay, now the first time we talked fractionally around the circle, which we still could do this, but we're not going to, I said 1 pi 6, 2 pi 6, 3 pi 6. You need to understand that. That's not necessarily the way we need to do it. We're always going to go, if you always go from the x-axis, it makes everything really easy. So this is 0, this is pi, which means it is 6 pi sixths, right? If I back up 1, I am at 5 pi sixths. If I go back to pi and then go forward 1, now I'm at 7 pi sixths, right? Then I can go all the way around here, which I know this is also 2 pi at 0 and 2 pi. So 2 pi and 6 is going to be 12 pi sixths. Back up 1, I am at 11 pi sixths. Okay? And all of my pi 6 angles are the ones that are closest to the axis because they're 30, so you don't go as far away from the axis. Okay, we good on that? So now we do pi fourths. So pi fourths. This is 4 pi fourths. We back up 1, we are at 3 pi fourths. I go back to 4 pi fourths, go forward 1. I'm at 5 pi fourths. all the way around is 8 pi fourths. If you back up 1, you are at 7 pi fourths. Okay. Thirds. 3 pi thirds. Back up 1, 2 pi thirds. 3 pi thirds. Go forward 1, 4 pi thirds. All the way around is 6 pi thirds. You back up 1, you are at 5 pi thirds. What is the reference angle for 5 pi thirds? Shortest way back to the x-axis. What's the reference angle? Pi thirds, right? Didn't I go here and back up pi thirds? My reference angle is pi thirds. My reference angle for 5 pi fourths? Pi fourths, right? One thing I'm not sure that I made clear in every class is when we're asking about reference angles, they're super easy. Reference angle for 5 pi 6 is pi 6. If you're asked about pi 6, the reference angle for pi 6 is pi 6. If it's in the first quadrant, it's its own reference angle, which seems strange, but that's because it's always acute and always positive, okay? I mean, you're not asked about that a lot, but that's how that works. Okay, so do you understand how to fill it in that way? Now, I want you to look at some things. I want you to look at these 3 angles in the second quadrant. What do you notice about how the numerator is related to the denominator? It's 1 less for all 3 of them. What about these 3? It's 1 more, which makes sense, right? Because we started here and we either subtracted 1 or we added 1 from the denominator, right? So if you get, because you're going to have to know what quadrant is 7 pi 6 in, what quadrant is, that kind of thing. So if you get 3 pi fourths and you can either, maybe you picture it in there, maybe you think, oh, I got 4 pi fourths and I back up 1, or maybe you're thinking the denominator is 1 less than the numerator is 1 less than the denominator, so I'm in the second quadrant. Like whatever works for you, but we got to make sure we know which quadrant we're in quickly. Okay. The numerator and denominator, there's not such a nice pattern over here, but you also know it's not just 1 more or less, I guess, and then you go from there. Okay. We good on that? What questions you got? Okay, so now I want you to fold this however you have to fold it so this is all you see, the other blank one. And then I'm going to give you a minute or so, and I want you, without looking at anything, without cheating on anything, without whatever, I want you to fill in all your radian angles to the best of your ability. Just what can we dig out of our little brains right now? Don't cheat by looking up here, but I'm going to fill mine in. Yeah, ready? You want to predict how corny it's going to be today? When you're done, you can check yourself with me, or you can check yourself with the other side of your paper, whatever works for you. Okay, I don't want to rush the process, but I'm going to have to so I can get through the rest of what I want to get through. So if you're not done, check with me on what you have so far and then fill in the rest, okay, so that we can do the next thing I want to do here. Overall, how do you feel like you did? Not too bad? Okay, that's good, right? That's not bad. This is still... Yeah. I wonder if they know that's on my recording every day. It's out there on the internet for everybody forever. Yeah, so, I mean, do you feel like you did better than maybe you thought you would if I told you to do this at the beginning? It's not that... No, you didn't do better. Okay, so now we're going to fill in some ordered pairs. Right, so we know that this one is 1, 0. We know that this one is 0, 1. Right? Pi 6. Use your left hand. Put your ring finger down. What is the x value for pi 6? Square root of 3 over 2. And the y value? 1/2. Good. All right, pi 4ths. Put your middle finger down. What's your x value? Square root of 2 over 2. What's your y value? Square root of 2 over 2. Pi 3rds. Put your index finger down. What's your x value? 1/2. What's your y value? Square root of 3 over 2. So guess what? That's true for any pi 3rds angle. If I ask you about 25 pi 3rds, okay, you're going to go, oh, that's a pi 3rds angle. Pi 3rds. I know it's 1/2 and square root of 3 over 2. Then the other thing you have to figure out is what quadrant are we in, so we know if it's which is positive and which is negative or whatever. Does that make sense? So all pi 3rds, you use the hand trick. It's only the first quadrant. If you use your right hand, you're not in the first quadrant, so don't do that. We're here. Okay, so let's talk about what we know about quadrants in general, right? This is always positive, positive. This is always negative, positive. This is always negative, negative. This is always positive, negative, right? You've known that forever, okay? So I want you to think about what that means. Here, sine, cosine, and tangent are all positive, right? Here, cosine's negative, sine is positive. What about tangent? Negative, because that'd be positive over negative, right? So the only thing that's positive, and so here, everything's positive, so that means they're all positive. Here, the only one of the three is sine that's positive. So here, cosine's negative, sine is negative. What about tangent? Positive, because I'd put negative over negative. Here, fourth quadrant, cosine's positive, sine is negative. What about tangent? Negative. So the only thing that's positive here is cosine. That's important to know. In the second quadrant, sine's the only positive one. Here's a little mnemonic for that. All students take calculus. Go around the quadrants. All students take calculus. That's your little mnemonic there for that. Okay? So that means that then when I go to fill in, let's fill in 7 pi 6. Okay? So I'm going to go, all right, pi 6, right? Here's my pi 6 angle. So that means for 7 pi 6, square root of 3 over 2, 1/2. And then I know all students take, I'm in the third quadrant, tangent's the only positive one, so these are both negative. They need a negative sign. Okay? Now I know when you're filling it in on the unit circle, it's obvious it's in the third quadrant. You know it's negative, negative. But if I'm just asking you blindly about 7 pi 6, you think, okay, third quadrant, and then you get your values, and then you can figure out if it's positive or negative. There's like a little process there. Make sense? So fill in, let's see. Let's do 3 pi 4ths. So here it's pi 4ths, so I know that it's square root of 2 over 2 and square root of 2 over 2. And since it's in the second quadrant, sine is positive, which means cosine is negative. Can you fill in the rest of your ordered pairs now? Fill in the rest of your ordered pairs. Tell me if you don't know how to do that. You don't know what I mean. I'm going to fill them in as well. Quadrantals too, don't forget about them. And remember, it's not always just about filling out the circle and how fast can we fill it out, because we're going to have to be able to do this without just having the circle in front of us. On Monday is when we're going to talk a little bit more about not looking at the circle and how to find them from the different quadrants and whatnot. Okay. All right. Give you like one more minute and then we'll have one more thing to do. We've still got a couple of minutes left. Actually, let me do this. If you're not finished filling them in, do you know how to fill them in correctly? Okay, then I'm gonna ask you to pause right there so we can finish this real quick. Did we already fill in the other circle? Yeah, we did. Okay, so go back to the circle that just had the angles on it. And let's do tangent real quick. Okay, and let's do tangent. We can do it from our little mnemonic, right? U, so this is undefined. R, square root of 3. 1, really overwhelming third wheel, right? So if 0 is 0, pi is also 0, right? What do you think about 3 pi halves? Still undefined, right? What do you think about 2 pi thirds? What would the value be without worrying about if it's positive or negative? It would be the square root of 3. All the pi thirds are all going to have a square root of 3 on them. In the second quadrant, is tangent positive or negative? Negative, because it's only sine, right? So then at 4 pi thirds, it's the square root of 3. Is it positive or negative? Positive, because all students take, right? 5 pi thirds, square root of 3, positive or negative? Negative, okay? Because tangent's positive in the first and third quadrants. So 3 pi fourths is the same as pi fourths, but it's negative. Negative 1. This one's 1. This is negative 1. So this is why I've been saying, if you know the first quadrant, you know the rest. You just got to know if it's going to be positive or negative. So 5 pi 6 is going to be negative square root of 3 over 3. And then square root of 3 over 3. And then negative square root of 3 over 3. And these are our, might want to write tangent values. Tangent data. Okay. We good on that? You have Delta Math assignments. Do them. Practice. If you do not practice at all, a little bit at this is not one of those things you can cram for at the end and it make any sense. Okay? Y'all have a great day.